Here we have characters problem in related rates. Okay, let's go with the information. The string of a kite is perfectly taut and always makes an angle of 30 degrees above horizontal. If the string is let out at a rate of 10 feet per second, how fast is the kite's height increasing? Okay, first let me draw a picture connected to the given information. Here I have drawn a picture for the given information. So here we have a right angle, and this is a point. Let's say this is point A at where the string is let out, and this vertical line represents the height of the kite. So now let me assume the length of the string as a variable x. So I assign a variable for the length of the string because it's getting increased because the string is let out from this point A. So when the string is let out, so the length of the string will increase. That's why I assign a variable for the length of the string. And let me assume the height of the kite from the ground level as y. So I assign a variable for the height of the kite. So because the height is also getting increased when the string is let out from the point A. Okay, now let's go over the information here. And the string of a kite is perfectly taut and always makes an angle of 30 degrees above horizontal. So this is 30-degree angle measure. So this is constant because the question is always makes an angle. So this angle measure is constant. So we have changes only in the length of the string and the height of the kite from the ground level. And also the question says that the string is let out at a rate of 10 feet per second. So that is the length of the string is getting changed 10 feet per second every second. So the string is let out 10 feet. So this length, this is x represents the length of the string. So x is increasing 10 feet every second. So whenever we have a change in a quantity, in calculus, the change in the quantity can be expressed using derivative. Since the length of the string is getting increased per second, here we have to express this change with respect to time because it's increasing per second. So how do you have to express this one as a derivative with respect to time? It's very simple. That is dx over dt. Dx means like change in x with respect to time. So that is 10. So here I am writing 10 positive value because the length of the string is increasing because it's let out. So in case if there is a decrease in the quantity, we have to write the value with a negative sign. Since the length of the string is increasing at a rate of 10 feet per second, I am writing this 10 with positive value over here. And they ask us to find how fast is the kite's height increasing. Here y represents a kite's height. So they ask us to find the rate of change of this y. It can be expressed as a derivative, that is dy over dt. So that is how fast the kite's height is increasing with respect to time, that is per second. Okay, now so here when I consider this right triangle and considering this angle measure, so this side represents opposite, and since this is a side opposite right angle, this is hypotenuse. This is hypotenuse, and this side is opposite. Okay, so here we have some information about the variable x, that is dx over dt equals to 10. So we have to find some measure about the variable y, that is dy over dt. So we have to use a trigonometric ratio which links the opposite side and hypotenuse. According to Secato, sine theta is equal to opposite side over hypotenuse. Sine, instead of theta, we have the angle measure 30 degree. And please remember, this is fixed, it will never change because the question says always makes an angle of 30 degree. So sine 30 degree equals to opposite side over hypotenuse. Either from trigonometric ratio table or unit circle, we can get the value of the sine 30 degree. So that is 1 half equals to, and opposite side is y divided by the hypotenuse is x. Let me write over here. Again, let me write the same equation over here. That is 1 half equals to y over x. Okay, now let me multiply both sides of this equation by x to get rid of the denominator over here. So the x will cancel out. I am getting x times 1 over 2 or 1 over 2 times x equals to y. Okay, now what I have to do is I have to find the derivative on both sides with respect to time so that I can use this information, and also I'll be able to get dy over dt. So which gives the change in kite's height. That is how fast kite's height is increasing. So let me find derivative on both sides of this equation with respect to time. And I'm getting 1 over 2 is a constant. Whenever I find derivative, if there is a constant multiplied by the variable, I have to keep the constant as it is. I have to find the derivative of the variable unknown. If I find the derivative of this x with respect to time, I'm getting dx over dt. Now on the right side, if I find derivative of this y with respect to time, I'm getting dy over dt. 1 half times. I know the value of dx over dt. That is a change, how fast the string is increasing. So it is given that the string is increasing at a rate of 10 feet per second. So we can plug in this chain for this dx over dt over here. then we get dy over dt. So 2 goes into 2 1 times, 2 goes into 10 5 times. So finally I'm getting dy over dt is equal to 5. So here I'm getting a positive value for dy over dt. So dy over dt represents change in the quantity y. So whenever we get a positive value for a derivative, I have to understand it is increasing. In case if I get a negative value for the derivative over here, so I have to understand this y is decreasing. Since I'm getting a positive value over here, so y is increasing. So how do you have to write unit for this one? So like when I consider how fast the string is let out, so it's given that is 10 feet per second. So here the distance is measured in feet and the time is measured in second. So we have y. Y represents the kite's height above the ground level. So it has to be measured in feet. And and t represents time, it's in denominator. So we know that the unit of time is second, feet per second. So that is the kite's height is increasing at a rate of 5 feet per second.